Do you understand so far? Okay, so let's see. So remember, okay. So remember, only for a volume of gas, the ratio of moles is the same as the ratio of volume. So 20 centimeter cube of butene. So this one is 20 centimeter cube. So the ratio is 1 to 6. So you just times 6. So 120 centimeter cube. And then this one you just 2 times 4, 80 centimeter cube. All right. So 1 decimeter cube and is 1000 centimeter cube. Okay. This one 500 centimeter cube. How do you do this? You take 5000 times 5 divided by 2. How much you get? 1, 125 centimeter cube. Correct? And this one is just 1000. So the ratio is 2 to 4. 2 to 4. So you must 2 to 4, 2 to 5. You must times 5 divided by 2. Get it? A 2500 is it? Correct? So, correct. Or am I mixing 10?
I can understand the number C.
C, oh, okay. So the ratio is like this. Let's try again, The ratio of, remember gas and gas only, So the ratio is 2 to 5. And here I tell you it is 500. So it's 500 times 5, but divide by 2.
Uh,
Get it?
why divide?
Because it's not 1 to 5, it's 2 to 5. Like this. I know. I put like this, then you understand. C2H2 to oxygen is 2 to 5. Again, so it's 500 to 125. Oh, cannot just times. So you have to see the number. And this one is 2 to 4. So 2 to 4 is double, so 1000. Okay. Here's the same concept. This one is also 2 to 15 to 12. Okay, remember liquid cannot. Only gas, only volume of gas. So 750, this is 750 times 15 over 2. 750 times 12 over 2. Okay? Right, can you understand? Can I? Okay. Now let's look at this. When 100 centimeter cube of bromine, hydrogen bromide, 100 centimeter cube gas. So always open the ice big and see it must be gas and gas. So this one is solid, so this one cannot. So it's only between this and this. Okay? 100 centimeter cube of hydrogen bromide. Sometimes teacher, I don't know which is which. You have to guess. Hydrogen bromide has to be this lah. Correct? Makes sense, right? So it reacts with 80 centimeter cube of ammonia. This one, 80 centimeter cube of ammonia. Okay? How much gas is left over? Okay, the ratio is 1 to 1. So ammonia to HBr is 1 to 1. So 80 will react with how much? 80. But how much do I give you? 100. So is that extra? Yes. So HBr left 20 centimeter cube. Do you understand? Do you understand why? Okay. Try and do question. Yeah. So this one, the one that is extra is called excess. So this one is extra, so it's called excess. The one that is less is called the limiting factor or limiting reactant. That means when you finish, I finish first, then you stop. Okay? Can you try and do 3 and 4? Okay? Okay? Okay, never mind, never mind. We try. Okay, so you see, 'kay. 100 of this reacts with 500 of this. Okay? So, who is excess? Obviously, this one is excess, right? So it's more. So 100 of this only need 100. Okay? So 200 oxygen used. Okay, correct? So 300 oxygen left. Is that correct? Okay, so that's the first thing we need to write down. We write down 300 oxygen is left. Okay, so it's 100, 200. Okay, how much of this is made? 100 centimeter cube of carbon dioxide made. And then 100 centimeter cube carbon dioxide made. Okay, so the total volume of all gases is 400 centimeter cube total. Do you understand now? Make sense? Did you try question 4 already? You done? Have you tried question 4? Okay, let's see. So 4 decimeter cube with 10 oxygen. Okay, so obviously 4 only needs how much of this? Because the ratio is 2 to 3, right? So 4 only needs 6. Okay, so oxygen left is 4 decimeter cube. Okay. Here is a trick. Ding, 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 ding. What's the trick? Gas. Ah, this one is gas. This one is a gas. That's the trick today. Okay, so water is in water vapor. You didn't see it? Okay, so I must see. So I must open the eyes. Okay, so this one, how much is made? 4 is made. And so this one 4, this one 4, this one 4. So water vapor made 4 decimeter cube. Sulfur dioxide made 4 decimeter cube. So you get a total of 12. Okay? Can? Can Okay. All right. So now we go to okay. So now we go to one more part. Okay, just now the one I printed out for you is this page. No, no, no. Is task what? Task. The second one I put out for you is task 12. Task 12. Okay, look at task 12. Okay. Now, let's say, I make for you something. Okay, I make cookies. Okay, let's say I have 10 bags of chocolate chip, 10 bags of sugar, 10 bags of everything, 10, 10, 10, 10, 10, and I've already done the math. It's perfect. I can make exactly 1,000 cookies. I can make exactly 1,000 cookies. So I make in my kitchen, bake, 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 bake. When I finish baking, I only have 990 cookies. What happened to the other 10? Some accidentally fall on the floor, some accidentally broke away, some accidentally fell in the mouth. Okay, so how many percent did you actually get? We got 990, 1,000 times 100%. So we get 99% yield. Understand? So we got a 99% success rate. That is what percentage yield actually means. Percentage yield means how much percentage you get. Okay, so let's see. Maximum theoretical mass. Theoretical means based on calculation. Like based on my calculation, I'm supposed to get 1,000 cookies. So theoretical is based on your calculation. Okay, so actual is how much you actually get lah. So now I have 96 grams of sulfur dioxide. This sulfur dioxide, I got 96 grams. You're supposed to count how much sulfur trioxide you get. Okay, what are you supposed to do? You're supposed to do amount of moles is mass over molar mass. Do you remember? Remember, molar mass means sulfur is 32, oxygen is 16 times 2. Okay? Okay, can you try and find it? You got 96 grams of this. Find out how many grams of this. Done? I forgot already. Okay. Okay, 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 okay. Don't stress, don't stress.
What's the answer?
75%.
Oh, wait, in percentage. Question wasn't asking for a percentage. Wait, do we need to do all ABC?
No, you just do A first. I thought you were asking me about the answer for B.
Oh,
Can I discuss? Okay. Okay. So for sulfur dioxide, mass is 96 grams. 32 plus 16 times 2 is 64, right? So you get 1.5. Isn't it 64?
Oh, times by 2. Wait,
No, 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 no.
wait.
Sulfur dioxide,
16, 32.
32 plus 32 is 64, what?
Oh, wait, this was 32. I didn't look at the period.
Oh, no, you have to look at the periodic
I thought I
table.
memorized.
Don't simply memorize the periodic table. No need, no need, no need.
Mhm.
Okay. So if this is 1.5, this is also 1.5, right? So the mass of sulfur trioxide is 1.5 multiply. So sulfur is 32, oxygen 16 times 3, 80. So you will get 120 grams. Okay.
Wait, I got it correct. But then please.
You know why? You go and put the 2 in front. Cannot, because then your working is wrong.
I mean, I didn't put it through, but
Eh?
I got different answers.
Okay.
I don't know.
Okay,
I
so
need spare paper.
this why I do front and back so that you can write at the back. So the other paper you can write at the back. No, okay. So that's why I always print single when I'm giving you questions like this because I know you all don't have notebook. So that I can write front and back. Okay? Can? Oh, I don't know when they're gonna finish renovating. It's driving me mad. Okay, so this is for here. Maximum of sulfur trioxide. Can? 120. Okay, Okay. So in the reaction, only
I was wondering
90.
why you had to calculate the moles again.
No, because
But
that's mass.
it's just the ratio, so you still have to calculate the mole.
Yes. Okay. It's only 90 gram. I'm supposed to get 120. I only got 90. So this is 75%, is it? 75. So my percentage yield. So three reasons why. Because some gas was lost. Not all sulfur dioxide reacted. You can also say the sulfur dioxide not pure. Okay?
Do we need to memorize it?
No, 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 no.
Okay.
Okay. Try number 3. Periodic table. Periodic table.
Okay.
That
I wonder what is gonna be those down that.
I don't know. All I know that I might kill them soon.
I hope they're prosperous so they don't have to maybe um, destroy all the things that they did.
Okay. 90 grams of hydrogen. Okay. So first we find the amount of moles of hydrogen. Where's we will put it, that's 45 moles. Okay. So this one is 45 mole. How much of this? So you see the ratio hydrogen to ammonia is 3 to 2, right? So it's 45. This one should be okay. So the mass is 30 multiply 17 because nitrogen ammonia is sorry.
I have 19.
Uh,
Yeah.
510.
Yeah.
Okay. So your percentage yield 153 over 510 times 100. 30%. Do you get it? Can you understand now? Okay. We do one last question and then we can move to something else. All right. Five. Give me that. When I don't want to talk, then they stop drilling. Yeah.
You want to
Okay, done? Very far. Okay, you haven't done? Okay. All right. So 1 kg, we need to use 1000 grams. Okay, so we use 1000 grams. So we find aluminium oxide, 1000 over 102. Do you know how I got 102? Aluminium is 27 times 2 plus oxygen 16 times 3. So it's 102. So, check. Oh,
Sounded like you farted.
yeah. It's like conspiracy. The moment I start talking, I think he's waiting for me to talk now. So 9.8 mole. Okay, so if this is 9.8 mole, okay, the question is asking aluminium. So the ratio is 2 to 4. Okay, so same double or half? Double. So this one's 9.8 times 2, 19.6. So the mass of aluminium, 19.6 times 27. So 529.2 gram. Okay, but you only made 500. Okay, so 95 or 94.5%. Okay, yeah, okay. All right. So for this question, okay, so same page is now 105. We're gonna go. So we've talked about if it's solid, as long as they give you mass, as long as you have mass in grams, you use this formula, mass over molar mass, correct? Okay. And then just now I've taught you, so basically amount of moles, we have three formulas, mass over molar mass. The second formula we just learned amount of moles is only for gas is volume over molar volume. And this one they already tell you molar volume is 24 decimeter cube. Okay? Okay, now the third one is for aqueous solution. Okay? What is aqueous solution? So I'm going to teach you aqueous solution. Times. Let's say I have a beaker, okay, and I have 1 decimeter cube, 1 whole liter, okay. Oh, seventh floor. 15 minutes. All right. 15 minutes, they will stop drilling, okay?
What?
Okay, okay. Come. Jeruk.
I'm
Okay, so if I put hydrochloric acid, okay, so you know hydrogen is 1, chlorine is 35.5, right? So HCl is 36.5, right? Now, if I put 36.5 grams inside 1 decimeter cube, I can say my concentration is 36.5 grams over 1 decimeter cube, which is 36.5 grams per decimeter cube. Is that correct?
It must be also frustrating for them because they also have to function.
Yeah.
Gram TMG.
Gram per decimeter cube. Yeah.
Why is there a minus?
Because it's
Oh, wait.
36.5 gram per decimeter cube. So if I don't put that slash, it's -3.
Okay.
Okay? Can? All right. Now, what happens is this is in the unit of gram per decimeter cube. Okay? If I tell you I have 36.5 gram, is it the same as telling you I have 1 mole? Same or not? Yes, because this one you add together is 36.5. Mass over molar mass is the same, right? It's also 1 mole. So instead of saying 36.5 gram, I can say it's like telling you you got 90% in your exam. Okay? And telling you you got 9 out of 10. Same or not? Same, right? 9 out of 10 and 90%. So concentration, okay, is 1 mole over 1 decimeter cube. So 1 mole per decimeter cube, right? Okay. The units are different or same? The units are different. The units are different. But the value is the same? Same. 90% and 9 out of 10 is the same. Okay? So, if I say concentration, then I have a problem. This is also concentration, this is also concentration. So we say this is concentration in gram per decimeter cube, okay? And then we say this one is concentration in mole per decimeter cube, is also known as molarity, okay? Yeah, it's also known as molarity. Okay. Now, when I want to do an experiment, do I need 1 liter of acid? So much acid, your teacher will kill you, right? So you only need a little bit of acid. So you take a little bit out. Okay. So let's say when you do an experiment, you only take a little bit out. You only take out 5 centimeter cube hydrochloric acid, 1 mole per decimeter cube. Okay. How much acid is that? So here comes the formula, the last formula. Amount of moles is mv over percent. So a lot of books also write CV. C for concentration, but I prefer to use MV because M for molarity. Same concept, it's exactly the same. M is one is the concentration. Okay? So the M is here. 1 mole per decimeter cube. The volume is 5 centimeter cube. But here's the thing, this one is decimeter cube. This one is centimeter cube. So we want to make it a same unit. Put it over 1000. You get it? So that's the formula.
One is from
Molarity.
so one, yeah, molarity is one. How many times from the
What is the volume there?
we are 1000 to make it into a decimeter cube.
Oh, yeah, divide 1000 to make it the same unit. Okay? 0.005 mole. Cancel? Okay. So how many formulas? Three. Amount of moles is mass over molar mass. Amount of moles is mv over 1000. And amount of moles is volume over molar volume. So there's three formulas. mv over 1000. This is only for aqueous solution. Okay? Okay. How do you know? Teacher, how I know? Which one to use? They will put here the unit. You will see the unit, this unit, mole per decimeter. Okay, so when you see this unit mole per decimeter cube, you know you need to use one mv over 1000. Okay, right? Okay, let's try. Okay, let's just try two very simple questions. Okay, you look at this page 104. Just do question 1 and 2. Okay, you did question 1 already.
Right. Push, I mean, what page?
Page 104.
Well, we already did question one.
Question 1 done already.
Now, 3 and 4.
Okay, now do question 2. Question 1 is just mass over molar mass. I want you to do question 2. Okay. Volume is moles times decimeter cube molar volume. So it's 12. Okay. 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 So remember, you only have three formulas. Okay. You only have three formulas. Wait, hold on. Okay. These two that I showed you just now, is it talking about the same value? Yes. So if I have gram per decimeter cube and I want to change it to mole per decimeter cube, okay, how do I change it here? If I have gram per decimeter cube, I want to change to mole per decimeter cube, I just have to divide molar mass. That's it. If I have mole per decimeter cube, I want to change it back, I just have to multiply molar mass. Can you understand? It's just divide because it's the same value. It's like 9 out of 10 and 90%. It's the same value. Okay? Like this, okay? Every time you don't know what to do, you look at the formula. So this one, remember, this one is gram per decimeter cube. Okay, and they give you the molar mass. So from gram per decimeter cube, they want you to change to mole per decimeter cube. You just have to divide the molar mass. 0.1. Okay, you just have to divide molar mass. Okay? Okay. Asking you the mass of sodium chloride. Okay, but what information they give you? 500 centimeter cube, 0.2. Okay, so you must ask yourself, formula 1, formula 2, or formula 3? One, 3. Right now, because there is this, that means it's always formula 3. That means you always do MV over 1000. M is 0.2, 0.01. Correct? 0.1. Sorry. Not 0.01, 0.1. Okay. Now, you're looking for the mass, right? So mass is formula 1. Moles times molar mass. Moles is 0.1. Molar mass is 58.5. Get it? Now, the concentration, get okay? Yeah. Okay, concentration of solution, aqueous solution, 5 decimeter cube. Which mass of 500 of this solution? So again, which formula do you use? Formula 3. Because you're given mole per decimeter cube, you must use formula 3. So you use MV over 1000. Okay, so sodium hydroxide is NaOH. 23 plus 16 plus 1 is 14. So the mass of sodium hydroxide, amount of moles times molar mass. So you get 10. Okay? Do you understand? Does it make sense?
I didn't know how to apply the formula, but I think
Now you know, yeah. So slowly, slowly. You just have to remember there's only 3 formulas. You just have to know which one to apply. Okay. Look at question 8. Okay, question 8, you need to apply 2 formulas, Okay. So, okay. Listen first, okay? I give you a clue what to do. First step, you calculate the amount of moles of zinc. You use formula 1. Second step, you calculate the amount of moles of hydrochloric acid using formula number 3. Okay? Then we'll compare which moles to use for hydrogen. Okay, you read the question carefully first.
I was 15.
Yeah. That?
No, it's the same.
Okay.
More. Watch out for change this.
Okay. Okay, 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 okay.
Yeah, okay.
Okay. Can I discuss now? Okay. Okay. Now, first step, you calculate the number of moles of zinc. 4.55 over zinc is 65, is it? Okay, do that first. The amount of moles of hydrochloric acid, you must use mv over 1000. This is m, this is v. Okay? Zero point 0.1125 mole. Okay? Did you get this?
Yeah.
Here's the thing, now, if this is 0.07, right? And this is 0.1125. Okay. Who is the one that is less? I have 0.07. I need to have 0.14. Enough or not? If I use 0.07, wait, if I use 0.07, okay, the ratio is 1 to 2. I need 0.14. Correct? Correct? That one understand? Okay. Do I have enough?
No.
No, I got not enough. I only got 0.11. Not enough. So who should I go according to? Should I go according to the one that is more or the one that is less?
Once.
Less. So 0.11 of this.
I heard this before somewhere, but I wasn't sure.
Mole of hydrogen. Wait, this disappeared for. Okay. Mole of hydrogen. Okay?
It's the last one, right? The last one is like compared to the things.
So no, so the zinc won't be used up. So if you take 0.1125, okay, divide by 2, you only need 0.056. You don't have so much zinc. You have too much zinc. Get it?
Also, you're just
You're only using a little bit. You
so
got too much zinc. No
by
need, no need.
two of hydrogen.
No, the zinc you don't bother. You don't
So
bother.
you don't need to.
If you want to know how much, okay, okay. Let's say I use this much, this one, how much zinc will I use? Half, right? Divide by 2. I only use 0.056 25 of zinc. This one I got extra lah. Do you understand or not? I got extra zinc. So I always use the less one. So I take this multiply 24.
Use your 0.125.
2.7.
Why do you use the same moles for hydrogen and 2HCl?
Because it's the one that is less. Okay, okay. I make sandwiches, I make sandwiches, okay. 2 slices of bread, 1 egg makes 1 sandwich.
But the egg is less.
If I have 1,000 eggs, I can make 1,000 sandwich. If I got 1,000 eggs and only 2 slices of bread, how many sandwiches can I make? 1.
Oh, one.
1 sandwich only. Okay. Then this one I only use 1 egg. Yeah lah, this one extra lah.
So you use the limiting one.
Yes, yes.
So the product is only one.
The product is less. The product is the one that is less.
Wait, can I just write that down?
Yes, you can write that down. And you can understand or not? This question is a bit hard. Yeah. It's okay, it's okay. We will do more questions like this. Yes, yes. Okay. When you're done, you try and do this question.
Wait, I still need to copy.
Oh, okay, okay.
Um,
Okay, the first thing you need to do is you need to calculate. Okay. You find the amount of moles of iron, and then you find the amount of moles of sulfur. Okay, can you do that first? Do that first. Step 1, step 2. Okay. Find the amount of moles of iron, find the amount of moles. Okay. So iron is 5 over 56 and sulfur is 5 over 32. Did you get that first? 5 over 56, 0.089 mole, 0.156 mole. Okay, can? Okay, let's look at the equation again. Is the ratio 1 to 1? Correct? Okay. Now, if you use 0.089, okay, so there's two options. This is the bread, this is the egg. Okay, this is the bread, this is the egg. So I got, if I got 0.089 and I use 0.089, I will make 0.089. Correct? Correct. Lah. That's right. Okay. But if I use 0.156, dun, 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 this one I will have to use how much? 0.156. Oh no! Got enough or not? Not enough. So can or cannot? Cannot. So this one is in excess. Okay. So the moles of iron sulfide is 0.089. And so the mass get it? So you must always use the one that is less. Okay, always use the one that is less. Make sense? Okay. Okay, for number 7, the first thing you do is you count the amount of moles. Did you get both of this? So this is so obvious lah. Okay, which one should be ammonia? Nitrogen, because it's so much lesser. So, but you must remember the ratio is 1 to 2. So 35.7 to 71.4. So the mass ammonia 1213.8 grams. Did you get this? Yeah. It's the same.
It's the same.
Wow. Can you use the same? No,
Oh, that one.
because you have to think of ratio. The ratio is 2 to 1. Okay. So if this one is
But
15,
still,
wait. If this one is 15.625, this one I will need double. I will need 31.25. Do I have 31?
no.
No. Okay. So my sulfur trioxide must follow the one that is less. So it's correct lah. It's this one. But this one is the one that is the limiting. Okay? Do you understand?
Yes.
Do you get it now? Okay.
Wait. So, oh, you need to find the bus. So, yeah, I forgot to write the session.
You want to see the steps from the one above, is it? Can see?
Practice covered.
This one is practice. This one is like learning a new, like learning trigonometry, but much, much easier. Okay?